So hi everybody. So we start our course devoted to foundations of data science. So this year we are going to include in this course several important topics for modern data scientists. First of all, we'll talk a little bit about modern software tools for data science. And Alexey Artemov will lead this activity. So he'll tell us how to use various command line interfaces, how to run data on a cluster, and other important things, how to develop Dockers. Ivan Nazarov and Rodrigo Rivero will help him. Besides these important tools, we also will consider topics related to modern data science, namely, first of all, causality. So if you would like to understand what is the relationship between random variables and what is even more important, in which direction this relationship actually holds true, that is some specific chemical compound influence disease, but not vice versa, which is important for drug discovery, for various economic modeling, and so we'll talk about methods how to uncover these relationships and directions of these relationships. And this is a very trendy and important topic nowadays in machine learning. Besides that, we will also discuss modern time series analysis. So, of course, some classical methods, but also besides classical methods, we'll consider various deep architectures. This is the second topic. The third topic will make a brief overview of reinforcement learning, so some basics of reinforcement learning, but I hope that this will be enough for those of you who would like to go in that direction. What else, Alexey? Do I miss something?
No, I think, for the vision part...
yeah, also very important part, which will be led by Alexey Artemov as well. It's nowadays, everybody is working with convolutional neural networks and images, two-dimensional images, but actually our world is in 3D. And nowadays we have a lot of sensors, like lidars, structured light cameras. Even on modern mobile phones, you have sensors using which you can measure depth. That is the distance from your camera to specific objects in a scene. And so it's very important to process this data, to construct predictions based on this data, which is necessary to reconstruct scenes around you from those measurements, and to apply these for virtual reality, augmented reality applications, for processing of medical scans. And so this is the fourth topic we are going to consider. So it will be a gentle introduction into 3D computer vision, and we'll discuss some modern deep learning architectures to process 3D data. So this is the overall overview of what we are going to have here. Concerning the course itself. So first of all, after each, or almost each lecture and seminar, we'll provide you, we'll send you a link to a quiz. So at the end of the day, you'll get a link to a quiz. There will be simple questions, so that please listen to the lecture and a seminar with attention, because this knowledge will be necessary for you to answer those simple questions in quiz. So this is just to control that you put sufficient efforts to listen to our presenters. Besides that, during the course, we'll have an online project. We will have a project, so that you will have to select one of 4 topics about the data science, reinforcement learning, 3D computer vision, causality, modeling of sequence data, and so either we will propose you some topic or you will select your own topic. Rules, how to select the topic, and how to develop the reports for the project are already in the JOT forum for the course description. Besides that, we'll also release some instructions with some details, and you will have an opportunity to ask questions on this matter. Anyway, you will have to develop the report and a short presentation and the video where so you present this presentation on a video, and the project is a very important part of the course. So this is more or less all rules we have here. Rodrigo, do I miss anything?
No, so we'll have daily a quiz after class. As it was mentioned on the chat, you will have basically 1 day to answer the questions. They will be online on Canvas, and we'll have the project that will be the topics that will be distributed next week.
Okay, good. So now I would like to pass the ball to Alexey Artemov, who will start the part of the course devoted to software engineering for data science. So Alexey, please share your screen.
Yeah, hi. So first I want to say hello. I'm not sure if you can see me.
Yeah, but your background is fascinating, Alexey.
Yeah, thanks. So now, yeah, same as yours.
But my background is cool. I'm in Skoltech now.
Yeah, you have a pass.
Yes, sure.
So I'm gonna share the screen. Can you see it now?
Yes, you can see it.
Okay, thank you. So this part of today's course, so we have 6 topics on software engineering coming. So today we will be covering shell scripts and Dockers. So here is how it will be structured. We will have, I will need to be showing things. I don't have any slides first. So I will need to be showing things just online as I work in the console. So, well, working in the console is typically a little bit hard to follow. So I don't think that, by the way, is the recording going on right now?
Yeah, so there is a recording of our class. I hope cool. it will be okay.
Yeah, perfect. I don't think that it's very convenient to just try to follow me while I'm coding or doing things in console, especially because people tend to do certain things really quickly in the command line, so it's not even clear which keys are being pressed at sometimes. So for this part, for today, I encourage you to maybe look at what I'm doing, and I will be trying to cover as much as I can in the best possible detail and try to ask questions. But please do it out loud, because I'm not seeing any Zoom window, and will not be able to answer the chat until at least the break. We will have a break of, I think, 10 minutes somewhere in the middle. So if and then we'll release all the materials, so you could take a look and basically try to do the same for your task. And I will send a few links with tutorials that I find particularly useful. So I hope that if you do some work at home, or you will be able to get on track with all these technologies, and or at least make yourself a nice reference. Okay, so let's start with the first part, which is the shell scripting part. So for the shell scripting part, we will be using the command line interface, and right here I'm using a command line interface. I basically am on one of the machines that our group actually runs. So it's a Linux machine. So I'm running a normal command line interface with terminal multiplexing here. So I have 4 windows here, and I will be working in some of these windows, and I will be commenting on the output that appears in these windows. So first thing that I would like to say is what I propose to be doing here. So typically in machine learning, we are faced with a situation where one has to run an application or some code that you didn't develop. So it's not really clear how to basically run it in a consistent way so that the results could be reproducible. So in this particular example, I will be showing how to actually launch a program and create a wrapper script for a competitor matter for one of our projects. So let's get started, and let me first show you what the hell am I talking about. In here I have the data sets. I'm just this is a real world project here. So we have a data set of HDF5 files here. So each of these data sets consists of 1K data items, basically. So we're going to have to process one of these data sets using a specific code. So this code cannot process HDF5 files directly. So HDF5 files are special containers for data points. For those who are not familiar with them, I forward you to the HDF reference. So they're binary files. They're not text files. You cannot read them out loud. This is just a binary file like this. So you have to first prepare your data. So the program that we will be running here, I will share the repository with you then, but that's the program that's implemented in a C++ code. So this is the program that we will be running. It's a typical command line tool that uses a specific library. Specifically, it uses this compute cgal : compute VCM function. So we will have to actually prepare the binary for ourselves, but the binary. So let me just start with doing this. So my goal is to create a reproducible, a more or less convenient and reproducible environment. And what I'm having here is only a bunch of scripts. So first I have a C++ program that is able to process the data that I need to reproduce some machine learning or non-machine learning method in this case, so some data processing method. So my goal is to run this program in a reproducible scenario here. So I will start with first creating a bunch of bash scripts and shell scripts and explain how this is done. Well, to start with that, I first I first will prepare the environment. So I have prepared basically the prepare script for you. So when you are at home and when you will be given the access to this code, you will be just able to run it. So I will not dive into details here. I will just show in the contents of this file. So all you need to do is just to run the prepare. And let's wait for a few seconds before. So what this script does, it's actually configuring the environment for us in a very stupid way. It's just downloading the library that is used in this C++ code that I was showing, and it builds the library, and then it builds the code itself, actually. So to start with, we need to be preparing this environment. The second thing that I have here is the Python code. So in here I have HDF5 utils. So HDF5 utils are Python codes that that Maria has prepared to work with HDF5 files. So what they do is this: they basically get a file and they split these files into a bunch of text files. Remember, HDF5 files were actually binary, but this program that I will be running, it actually accepts only text files. So to start with, I will need to split the files. So let me first show you very briefly how this works. To do that, I will start with the files that I have prepared. So to start with, I will be running this. Let's say I'll just create myself 2 temporary directories like this, and in here there are, so in here we have the Voronoi input and the Voronoi output. So these are the 2 temporary directories that I will create myself. So next thing that I will do is I will actually pre-process the data for myself. So I hope you will well, sort of basically get into what I'm doing, what I'm trying to do as I actually, work. So first thing I need to do is I will have to output. I will have to pre-process this data, Voronoi input and the input file. So let us run this. So it actually, what it really does, it's actually just processes this data and writes it down as a 1K XYZ file. So XYZ files are actually text files. You can convince yourself that they are text files. Let's just look into them. So these files are actually 3-dimensional data points. So we're working with 3-dimensional data in our group. So this is just a point cloud, a 3-dimensional point cloud. So here we have the Voronoi input is a 1,000 3-dimensional point cloud. So second thing that I will need to do to create this kind of a reproducible script is I will need to run actually this program. So to run this program, I can just execute it. So when I'm typing the name of the program or the name of the binary file, so recall that I have actually compiled myself a binary file here. So this Voronoi that is displayed here in a different color is actually a binary file, and this is the source file. So I can run this program, but this program actually requires input data, output data, paths, and the parameters. So this is the typical thing when you are working with Linux. So let's start with passing in the data. So this program only accepts one of these 1,000 files at once. So it cannot process all the input files simultaneously. It can only process them one by one. Okay, so another thing that it requires is a bunch of parameters, and you will always have some parameters that you don't know what they mean in machine learning when you're comparing to methods developed by other people. So you typically won't be diving into each and every method when you need to compare to it, but you will typically just use the binaries provided by other people. So let us run this code. So basically, it doesn't print a lot of things. It just does the processing behind the scenes. And so what it okay, let me recreate this folder because there was something inside it already. Let me run it again. Sorry. So there's the output. Now it's empty, but when the program has exited, it's actually producing a bunch of output data. You can actually look what's inside. So it's some data format that that you need actually. So here we have this output. So what we need to do is we need to actually first we need to split the HDF5 file into a bunch of input files, then process each input file using this Voronoi program, and then merge the results into the resulting HDF5 file so that it actually has the same format. So it's easy to compute metrics, so it's easy to distribute or do something. So this is a very typical situation in the machine learning when you have some method that you downloaded from the internet that is relevant to your research and that you want to compare to. So how do we do this? So let's start with writing, basically a very simple bash script. So in here, I will just show you how to do the things from scratch, but I will actually provide you ready-to-use scripts in the end. So let's start with just basically writing a dummy bash script. So the dummy bash script looks like hello world, and it can be like this: echo hello world. If you save this script, what you can do is you can do bash hello sh, and it outputs the hello world for you. Okay, so remember we have only written the hello world here. Actually, to save time, I will be running scripts, the dummy ones in here. So one thing to note first is that most of the scripts are typically invoked not like bash and then the script name. They typically are invoked like this, hello sh. But to do this, you need to have a executable file. So first thing to do is to make this file executable. chmod +x hello sh. And when you actually look at hello sh, it will display that it has this X flag here. But that's not enough for the code to be runnable because, well, in this case, it's runnable. But typically, the second thing you would like to do is you would like to tell the interpreter what is the program that should run this script. So one thing to do is to put like this, bin bash. So this first line that starts with the hash and then the exclamation mark, that it tells the interpreter, what is the command that the interpreter should run to execute this script. So it's going to write you the same. But you can do also something different. You can try do like this, user bin Python, for example, and it will run the script invoking Python. In this case, it is not going to run because it's not a Python script, right? But you can do print xxx here and comment out this thing, and it's going to run, right? Because it's now being invoked from Python. Okay, but we're using bash here. So first thing to do is to tell the script to actually execute. So so remember, we're solving a very particular problem here. So let's just try. So we had this few commands that we have been running. Here they are, right? So this is the command that I have been running. So let me just type all these commands directly into the bash file, because this is ultimately what I want. So this is what has been done in step 1 of this tutorial. So step 1 is just like this. So I copy-pasted the commands that I have been running into the bash file. That's exactly what I have here, right? So 2 additional things that I did here is that I created 2 directories for the temporary files that I have. So let us just run this particular file and Voronoi input and Voronoi output is something I will remove it. So let me just run it step 1. So as you might see, there is this. While it is running, I will show you a few more things. Session 1. So this step 1 here also has this set minus x. So this set minus x tells the interpreter, in this case the bash interpreter, to actually print every line as it is executed. So bash has a bunch of options that sort of control how things are performed. So in this case, this set minus x tells the bash to actually print every line as it is executed. So it will both execute the line and print it. So these lines are indicated with a plus sign like this. So you can see, I'm not sure if you can see my cursor. Well, I hope you can. Well, you can do like this. So here are these pluses. So I hope I will be able to actually erase these afterwards. Okay, good. So as you can see, so this is the script that actually the script actually was completed. So it really generated us the same input, the same temporary input and the same output as we actually wanted. So it's just the same as if we were doing all this by hand in the command line. Okay, so what else to note? As you can see, this script is sort of working, but it's not very general, right? So well, first thing to note is that we have to actually hard code all the input and output directories. So to actually process more data, we will have to actually edit the file. Let's say we want to process file number 1, so I will have to edit the file, then file number 2, file number 3, number 4, and this is very stupid. So it's not about programming, right? So it's more about being a monkey. So this is not the way it should be, obviously. Another thing that is really bad is that this code actually has hard-coded names for the scripts itself. So it relies on these HDF5 utils to actually pre-process the data before it goes into the binary. But the path to this library is actually also hard-coded. Okay, so that's also bad. First thing to do here is to actually introduce some kind of parameterization to this kind of script. So what I will do right now is I'm going to try to rewrite this script so that we will have more control over what's going on. So to start with, I will actually declare these few input and output directories as variables. So to declare a variable in Bash, you could just say like this. So it's like it's an output dir, so it's going to XYZ input dir, and then I just paste it. Sorry, I will paste it. So this statement here is actually declaring me a variable. So to understand what a variable is, well, a variable is generally some string holding data. So these variables that are used in Bash are actually called environment variables, okay? So environment variables can be local to your script. So in this case, I am declaring a local environment variable, but they can also be defined by the actual environment itself. So if you type in the env command or the env command, you can see that you have a lot of environment variables defined in your environment here that you're working in. For instance, there's an environment variable that's called the $shell. So to access an environment variable, you take its name and prepend a $dollar before it. So, and the echo command just basically prints the name of the variable. Okay. Another thing that you have is, for instance, the $home. Another thing that you have is the, I don't know what, the user probably. So these are the environment variables that are defined by the system. And here is the environment variable that is defined by the script. So here we just take the name of the variable, the equal sign, and then the name of the file name. So note, I don't put a $dollar here because that would access the variable, not set it. And I also don't have to put any quotation marks or anything in here. So it's not necessary. You can put a double quotes here, but it's not necessary. Okay, and now, because I have actually cut out a variable from here, I will need to access the variable. So now I will just type in the actual name of the variable. So what is this going to give me is that when this line is executed by the Bash interpreter, then it will substitute the value of the variable for the name of the variable. So we'll just take the value and substitute it for the name. So you can make sure, so it's step one, if you execute it, so you can see here that actually in here, the XYZ input dir is set to a certain value, and then here it is the XYZ input dir. So the name got expanded and it got substituted for the variable, okay? So it works as previously. So let me do a little bit more for that. So we'll have the input file name, input into HDF5 file name is like this, and I will have to reference it in here. So I also prefer doing some line breaks so that the script gets a little bit better formatted. And also you don't have confusing things. So one parameter per line works good for me. So so this is what I'm going to do. So so in here there's actually some input file name. So this is like the xyz in file like this. Oops. So xyz in file is this. So as you might imagine, it has so when you do all of that by hand, it takes some time. So I need to put $1 in here, and you will generally need to reformat the file that you're actually doing, that you're actually working with. So let me actually show you the result of such reformatting. So let me actually edit the step 2 variables file. So here is the resulting file that I obtained when I finished the reformatting. So when I finished using the variables. So in here, so this is the way it actually looks like. So you may note that all of the input data and all of the intermediate files and even the names of the scripts are enclosed in variables. So this is extremely common to Bash. So instead of calling the script by its name, you actually create a variable and put the name of the script into that variable so that when the script changes the name, you can just edit the variable at one particular place, because you can have invocations of this script in multiple places. So you have it here, you can have it somewhere else, and you may edit the name in one place but forget it in a different place. So if you're creating a script variable that holds the name of the script and you edit it in one place, this guarantees that when the script name updates, you will actually be able to update it in every single place. Okay, so another thing to see here is that this is a variable that actually holds a value of a different variable and is concatenated with an additional string here, right? So this is also extremely common. So when you have a lot of configuration going on, so if you need to have a source directory for the Python code and then a few scripts that live in this source directory. So you can see that in here, if we do ls of contrib and then Python and then HDF5 utils, we have a few scripts here. So it's very reasonable to actually define a variable that actually holds the directory of the HDF5 utils and then define a few scripts that depend on that variable. So this is the code that actually concatenates to strings. So you can work also with variables in a command line. So for instance, you can define a variable like my var here and assign its value to x, 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 y, y, y. But once you press enter, my var stops actually existing. So if you try to echo my var here, no, it doesn't stop existing. It exists. Sorry, it exists as long as the shell is open. So you can echo it like this, but you can also do it in curly braces. So why do you need a curly braces? So curly braces are because sometimes these variables are concatenated like this: my var, and then a name. So it gets concatenated. So it first expands the name of the variable and substitutes the value for the name, and then it actually appends this name that is actually interpreted as a string to it. So we get as a result this. Another way, if you just remove this curly braces, then the variable expression will not happen, and then you will get nothing because there is no variable that's called my_var name. Okay. Another thing that people typically want to do is to enclose the variables into double braces. So in this case, it doesn't do much, but if my var is blah, 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 so it has spaces inside it, for the echo, this doesn't really matter. But if you would like to do the ls dollar my_var, so you can try. So of course it cannot access the blah 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 because there's no such file or directory. But then, so I'm not sure how this works really. Right. So if you don't enclose these in double quotes, then the blah blah is just so it tries to interpret this several words separated by spaces as different commands. So the first command is a variable assignment where my var is actually blah. So if you try to echo $my_var, it's actually, oh no, it's the whole line failed. Okay, so it's actually unable to perform assignment here because the right-hand side is not a valid expression because it didn't find anything. But you can try ls-l like this. It won't work as well. Okay, so that's it about the variable assignment here. So you can basically work with variables. So in here, I have all variables put on curly braces so that they are actually expanded. So this is called variable expansion. So all I have done is this. I have first replaced all the script arguments with variables. And second, I have replaced the script names with variables. And there's nothing more going on here. So as you can see, it is as simple as that. So now we end up with statements like this. So you execute a split script and pass a bunch of parameters into this script. And these parameters are read from the environment variables. So now what I want to do is I naturally want to actually process all the data and not actually the not really a single file here, because you remember that we have like maybe 1,000 files in here, but I only process one, and of course I need to process all of them. So what do? I naturally want to use the loop. So I want to actually use a loop to read the files one by one and actually process them one by one. So this is how do I do loops here? So one simple way of doing loops is like this. So you can try and organize yourself a for loop. So Bash has for loops. So how to use a for loop? To use a for loop, I actually need an array of things. For instance, if I have a variable that's like this my var that says blah blah blah, I can iterate over my var. For instance, I can do v in $my my var do echo $v done. So in this case, it only printed one thing. To actually print, I think it has to be like this. Oh, so let me actually show you. I really don't remember how to work with arrays. Boom, 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 boom. Just a second. Yeah, I confused this one. Well, maybe one has to define it in a different way a little bit. Yeah, so so when I defined my var as a single string like this, it's interpreted as a atomic object. So this is a string, just a single string. But if I define it like this, so this becomes a list of elements. So for instance, it's like foo bar buzz. So this now is an array or a list. And I can iterate using a for loop over an array like this. So I access the variable, my var, using the variable expansion here, but I also indicate that this is an array by putting in the square brackets and this @ sign here. So this is a one-liner for loop. So it actually prints you one variable per line. Okay. So the next thing I would like to actually do, so I have this ls command. So ls command is a normal Linux command that actually prints you the contents of the current directory. So it turns out you can actually capture the output of the ls command or any other command into a variable. So how do you do this? So it's as simple as that. You do the $, and you put round braces, so that you put the parentheses around the command. So it still runs your command, but then it actually, you need to capture the output. So my var is the output of this ls. So you can now actually echo my var, and you have all these file names. So as you can see, so this ls, it actually printed something, but this this output, it hasn't been printed to the console, but it rather has been assigned into a variable myvar. Okay, so you can of course use all of your favorite modifiers in the command, and you will get what you actually typically get. Or you can use a find program, which is just the same. So the find is actually traversing the directory recursively and prints everything it bumps into. So you can find here, you can find in the one directory above, you can do the contrib cxx, something like this. So it actually traverses you. You can do, you can only output directories, you can output only regular files. So it's a very, very versatile command. So you can, of course, you can do the same with find. So you can do my_var is $round brace, and then you close the round brace. So if you echo my var, it's going to print you the contents of what has been printed by this command here. Because we are having all this data here as separate files. So it's really easy to actually find, and then I am supplying the name of the directory. So what is going to do, what this command is going to do is it's going to look into that directory and output all the files that it encounters. But I will additionally say that I only need the regular files, because it still can output me the directory itself, because the directory is sort of it holds itself. So I'm going to just print the name of the directory, the name of the regular file, sorry. So sort of I'm going to actually assign the output of this command to a variable. So now what I can do is I can actually iterate for f in $my var. So in here, and I can just echo f and then done. So what this actually does, so let me show you that again. So what have we done? We have actually looked into the directory, printed the contents of this directory, and captured it into an environment variable. This is an extremely common thing to do in bash scripts as well. So next thing, what we have done is actually we have iterated over this printed contents and just printed them again. So we are iterating over my var. So in here, my var is not an array, really. It's just a string that is a new line separated. So this means we don't need to put anything like this in here, but it still works, but you don't have to do this. So this means that in here, I can do just the same. So what I'm going to do is I'm going to do the XYZ files, and I'm going to assign it to the environment variable. So I need to find in this directory with the type f, and I assign it to the XYZ files here. So XYZ file I iterate over this array actually, and what I do is I actually process each file separately. So in here I have this XYZ file environment variable that gets assigned value each time it actually each time the loop sort of increments. Yeah. So let's basically check it. So let's do the step to variables, because this is the file I am actually editing. So let's see what's going on. So it first needs to actually split the data into the XYZ files. We're going to have to wait for maybe 10 seconds while it does that. And then, so this is what has been going on. So the bash interpreter has seen that we're executing the find command. So it has printed the entire assignment here because we have requested it to print everything that is going on inside the file. And now what's going on is actually this. We are actually processing the file one by one. So one bad thing about this is that you have a lot of files. If you have a lot of files, this means that you first need to find all of them and allocate a buffer for these, which is sort of suboptimal, right? So it really cannot start executing this loop before the find commands is really finishes. You can also actually because we don't really need this environment variable, you can also try doing this like this without actually capturing any of the output whatsoever in a separate variable. So it's also possible to do it like this. But that is really not the only way of doing this. So let me show you a few other ways. So this is the very same script, but it is updated such that it has all these variants of looping through the file. So this is the first variant that I was showing previously. So you know that. So what we actually do here is we find anything that is in the input XYZ dir that is a regular file and that additionally matches this file mask, right? So it's actually a very versatile program. So you can do the Voronoi, find Voronoi input that has it's a regular file and the name. Let's say it matches. It has a 5, like maybe. It has a 5 in it or something. So it's going to only open you to only print you the strings that have 5 in their name. So this is matching the file against the wildcard here. So this is a simple for loop. For loop to start, the find must actually complete. So this is not a very optimal thing to do. A more optimal thing to do is using the while loop. So the while loop, let me first show you what's a while loop. Okay, I'm going to show you in this toy terminal here. Move out. Let's see. Okay, so for the while loop to work, for the while loop to work, it was like this: a while condition, do, done. So it looks really similar to the actual for loop, except that it's checking the condition. So, for instance, you can check a condition like this. You can start. You can do like echo $I. And then you can do the I is I plus 1. So in here, I'm showing you a few new concepts. So here is the double curly braces. So double curly braces can perform arithmetic. So actually in Bash, no, that's double curly braces with a dollar perform arithmetic. So in Bash you have a single square braces, double square braces, a single curly braces, double curly braces. Sorry, there were the parentheses and then the curly braces, and you can additionally prepend the dollar sign. So this and this we will not cover now, or we actually no, we are going to cover it now. So if you would like to check that $I is less than, let's say, 5 here, you will need to actually have, I think, so to talk about it, we will first need to understand what is going on here. So this has a syntax of while condition. So this condition is actually a Linux program. So Linux programs, they actually return a value. So Linux program must return a value. When the program returns a 0 value, this means the condition is true. So for instance, you can say ls. So this ls, it not only prints you the data here, the strings, the files that it has encountered, but it also returns you a value. How do you understand what value is being returned? Well, most of the time people care about zero or non-zero return codes, because zero return codes are by convention, well, by convention, they typically mean that everything is okay. So ls, or ls that just prints something, or ls slash, or ls slash home, or ls minus la home. So it actually, it doesn't get you any error. This is, everything is working normally. So this is typically actually really printing you data and exiting normally. But you can actually, so there is a special variable that actually prints you the exit code for the last executed command here. So it's, you can access it by calling question mark. So it's funny, but in Bash, unlike many other languages, variables can be named like this. So $1 is a normal variable, $0 is a normal variable. It's actually you can print it. So $0 is the name of the currently executed program. It's always the case. So you can also say $hash. You can also say $@ and a bunch of other things. Even $ampersand does something. So that's actually the last executed command. So this $question mark, it's actually, if you print it, it prints you the string value of the return code for the command. Okay. So if you do the ls and then the file name that doesn't exist, and then you try to print the return mark, so the return code is actually 2, which is non-zero, which indicates an error. And the error is it could not access the file because there's no such file. So in this sort of is supposed to mean that this program has exited in an emergency way, in a non-normal way. So actually in Linux there is the command exit that can optionally be supplied with an exit code. So exit 0 means you must exit the program and return 0 exit code. So you can supply it any return code you want, like this, right? But typically people only do 0 or non-zero because it's easy to check. That's the first thing. So Linux programs all have exit codes. The second thing, there is a program that's called test. So test is actually Linux built-in program. So you can view a manual for test like this. So what this program does is it tests for existence of variables, strings, files, directories, and whatever you ask it to do. So for instance, you can, to check if a file is a regular file, you can try test -f and then the readme. So it visually does nothing, but what's really important is that if you echo the $question mark, it's a 0 return code. So test program has exited and returned 0. So if you're trying to access the file that doesn't exist, the test program outputs you non-zero. So this is crucial to understand how to actually work with a lot of things in Bash or in shell scripts. So what you actually would like to do here is to, well, not exactly run a test, but to check if a certain, so for instance, if a certain variable is less than or equal to 5 in here. So to do this, what we have to do is we would like to actually do this. Wow. Sorry about that. So this this can actually check if an integer is less than, so LT means that's less than another integer. So E here is an integer. So we can check if this is less than 5, then we can echo and then increment it. So I'm removing all that. So we would typically do it like this. If while test, and then let's try running it. So it printed the hello world, and then it printed the values of the variable that were gradually incremented, right? So let's remove the hello world for us. So there is a shorthand for test, and it is indicated in this manual. So you can run it either as test expression or as a square bracket expression. So a square bracket, so this is a really fundamental thing about shell scripts. The square bracket actually invokes a program in Linux. It's not a language. It's not a bash language feature. It really invokes a program, checks for it, return code, and compares it to 0, okay? So this is mind-blowing, but it works. I hate it, and this is why bash is called a write-only language here. So it's really hard to read bash scripts. But once you know how to do this, it becomes extremely, it becomes a lot easier. But let's get back to our script here. So option 2 would be to actually so option 2 would be to actually, so this is a little tricky. So let me first show you what this find minus print 0 shows us. We have done this find before. Can I move it somewhere? So we have used find before like this, but you can also do print 0 here. So this is going to print all the files on one line, appending a 0 character after each file. So this modifies as the output of find, actually. Next thing is this. You might have heard of pipes in Linux. So pipe, or a vertical bar, well, you can basically compose programs like this. You can actually sort of take an output of a program and put it into a different program like this. So anything that a program prints on the standard output, so that is anything that it gets printed in the console, is read by a subsequent program like this. So this find, it actually gets piped into the grep program. I'm not sure if grep program is very familiar to you, but anyway. So we can actually pipe. Well, you can do a lot of things with that. For instance, you can. What can we do? We can. You can open Vim with this. you can do all of the programs can actually accept standard input. So, for instance, in this case, I am only printing the strings that have points _1 in their name. So we can modify something and only print the strings that have points _18 in their name, something like this. So it turns out that you can also pipe into while a while loop. So you can actually do it like this. You do while read, and then the name of the variable XYZ file. What we can do is just echo $XYZ file and then done. So what this thing does is that it prints all of the output of the find command into the read command. So what the read command does is actually, so there's a command that's called read, and if you just type read, it will ask for some input from the keyboard and then quit. So it seemingly does nothing, but in fact that's not true. So the syntax of the read command is like this. You read into a my variable. So if you type something and then echo the my var, it will actually put the red string into the my var variable. So read, actually, there has to be a variable. So anything that it gets as input, it puts into a variable. So anything that it reads from a standard input, like int echo something, and then pipe, and then read my variable, gets flushed into my variable, right? So this same thing we can do in the while loop here. So in the while loop here, what we have done is we print a lot of things line by line on the console. And then we can, in fact, pipe through the while loop into the read command and into the variable XYZ. So this is sort of equivalent to the for loop in that it will also iterate over every file. But in this case, you don't really have to wait until the find command finishes. So we can just basically execute the loops here. So for the next parts, I will comment out the splits here, so we don't wait for it like this. So we don't run the split over and over again. It's silly. But then what's going on is just so it executes the find, but then it actually pipes what it has encountered into the standard output, and it's read by this read -d command, read command. So please forget about the print 0 and IFS and -d for now. It doesn't matter. I can remove it, it will still work in this case. But this is to ensure a little bit more robustness here. So this is a second way of doing the loop here. And then there is a third way of doing the loop. But I would like to basically to skip it because we don't have too much time, and I want to cover a little bit more. But I will just say this, that you can actually execute a binary directly in the find loop. So find actually has a -exec command, a -exec option. So for instance, you can do find here -exec, and then you can do exec, and then there should be command like this. And these curly braces here, they actually hold the what has been actually really encountered. So for instance, you can do ls minus la, and this is what's going to happen. So it has found everything, and it has run this exec minus la, supplying it with the encountered file name every time it hit a file. So for instance, you can only do this to directories. But that's funny because it has encountered this current directory and it has printed everything. You can try it with files. It will only output ls minus la, but only for files because I have requested it to actually print the file. And a lot of other things. So you can actually minus name, step, so you don't step asterisk, so you don't print it for the README here. So it only prints for the step, for the files whose name match step asterisk. So that's the only thing that changes here. So it's a really simple syntax, and I really encourage you to actually look into it. So in our bash file, we still have several flaws, several major flaws. So for instance, you can only run the file like this. So you would do step 3, and then you cannot supply it any argument. You cannot understand what's going on. So it will just execute. So it's a black box for us. So it's not good. What I would like to do is I would like to actually supply it with actual command line arguments. So, for instance, I would like to have to actually work with it like this. I can actually supply it with like a file name, with an actual file name that it will have to process. So for instance, I want to do a different file, but right now it will just simply ignore the file. So you can see it still works with this val 0 and not the one that I supplied it, because it just doesn't have the code to parse the command line arguments. So let us actually get this file, the capabilities to parse the command line arguments. So that is done by the Linux command that's called getOpts. So the syntax of getOpts is like this. So getOpts, string args, and then the opt. So what it will do, it will iterate over args that are formatted like this. So let's start with this. Let's first understand how we would like our program to be invoked. So the program should be invoked like this. So the name of the program is actually step 3, and then we would like to do the input file, and then the output file, and then I would like some options here. So some options that are these. So for instance, I would like to do the -r offset radius, -r conf radius, -t threshold, like this. So this is the way I would like to invoke my program actually. So to do this, I need to just parse such strings. So how do I do this? So the getOpt is actually it actually can give me a nice tool to parse such strings. So for instance, let's try and first parse the -e option. So to do this, the string has to look like this. So it has to have the e and the colon behind it. So sorry about the z. The z should be there. So to do this, I would do it like this. So while getOpts, I would like to do and parse the options. So this getOpts will hold all of the possible options that my program will possibly be supplied with. For instance, let's try and first do the input and output file names, right? So what it does is that actually you can let's for instance let's start with actually echoing the value of the opt here. Let's actually get opts, get options. So obviously you need to execute like this. So it really executes, and it's all right. So -I, so something, right? So in here we have iterated over all of the options that getOpts was able to parse. So it sees that there should be an option that is the short option, it's called, and that is named I. So what we need to do is we need to understand what is the actual something, what is the actual string here, what is the actual string that the user supplied us, and there's also there's a second string here, right? So if I invoke it, it sees that there are these options, and it also sees that the opt argument, so this opt is the variable, an environment variable that gets set by the getOpts program, and it's equal to I. So it's actually the string name of the short argument here. So options that look like this are called short arguments, and options that look like this input file are called long arguments. So there are a bunch of, I'm sure you know the argparse for Python. I'm sure you know a lot of other command line interface programs that are able to parse both long and short arguments. But here I will only just cover the short arguments here. So like this, it says that it's an illegal option if we're trying to invoke it with an option that it doesn't know. So as you can see, so this strings is actually defines the set of possible options. So now what we need to do is we actually need to understand what is the value that it gets associated with an option. So this is captured by the opt-arg environment variable. So in here you can see that echo E and the opt-arg resulted in echoing E and a string here. So let us then, so if we are iterating over options and values of the options, then what we need to do is we need to set our HDF5, for instance, we need to set this particular, so some bloody commercial thing that we all hate tried to call me. Okay. Sorry. Yeah. So let's continue. So what we need to do is we actually need to replace the value that is hard-coded here by the actual name that we are supplied from the getOpts. Okay, so how do we do this? So we actually will need to use the case clause. So there's the case clause that looks like this. So you sort of open and close it by first typing in the case and the ESAK. So in Bash, a lot of things start with like this, like if and then phi. So this if and phi are sort of corresponding to each other. So case corresponds to ESAK. So what we try to do right now is we'll try to look at the case. At the case. So let me recall how do actually parse the case. So the case really implements you a choice operator here. So it looks like this. So for instance, you will need to so what it looks like is this. So case value, and then case var, and then there's the value 1, and then there's, so it's do something, and then the semicolon, and then there is a second value that's do something. So what happens here in this case clause is this. So the interpreter examines the value of the variable. If the value matches the requested value here, so it executes the statements that are encountered in this clause here. So double semicolon, it actually signifies that you should break from the case clause here. So one interesting thing here is the var should actually be so the value can actually be regex. So for us, this means that you can do something like this: name, then there's an asterisk, and then the something. So it will match a lot of things. Or you can do name question mark something that will match name and then one arbitrary symbol in between and then the value. So let us finish with actually adding the command line parsing here. So what we'll do here is that if we encounter the input HDFI file name, then we are just setting it to the opt arg. We're just copying the value of the opt arg here. So if we encounter O, we need to actually set the output HDFI file name to the opt arg. But what happens if we are supplied with some other option? So to do that, to parse that, there is actually an asterisk clause. So what we would like to do is probably we need to output that we don't know what to do here, and actually exit, producing an error message. So this is what is going to happen if we input the actual setting that it doesn't know. So that's the way command line arguments get parsed into. So now we don't need the input HDFI file name because we are supplied with one. There's only one particular thing about it, that it still can run without being supplied any arguments here. So if you try to echo the value of the input HDFI file name without any arguments, let me show you what's going to happen. So the get opts didn't actually produce any error because, well, it's possible to not have any arguments. But the input HDFI file name is no longer set.
Alexei?
Yeah.
I see that we have now a bathroom break.
Okay. Yeah, let's do a break, and I believe that everybody is very tired already.
Yeah. Also we can discuss the questions in the web chat.
Sorry, I wasn't looking in the web chat.
Yeah. So Alexei, in principle, I would propose the following format, which I already used for some other lectures by Zoom. Like you stop every 15 or 20 minutes or so after each section, and maybe have some rest. You both you and colleagues, And also you discuss with students some questions from the chat, or they can ask questions by voice, whatever.
So I just propose to ask questions by voice because while I'm on the command line, this is
Yeah. But for in case of during breaks, you can read chat. So this is another option.
Yeah. Let's do this during breaks. Okay, so let's basically stop every half an hour to discuss questions. That's reasonable. So now we have a break for 10 minutes, right?
As much as you would like.
Yeah, so let's get back at 14:10.
Okay.
Okay. Should we get started?
Yes, let's start.
Mm-hmm. So there were a little bit there were some questions regarding the previous part, and I think for the next part we still have 1 hour and a half, and so I propose to maybe answer the questions, finish the scripts part quickly, and then just do a real quick overview of the Docker. Unfortunately, we don't have more time for the Docker. So for the curly braces, there was a question about curly braces. So if you're having my var like this, and you're trying to echo, why do you need? Why can't you just have my var and my? Sorry. Why can't you have my var? Why do you really need my var with the curly braces? So the curly braces make your variable separable from what comes after it. So if you're doing my var name like this, it's not going to be confused with a variable having a different name that doesn't really exist. So this is the answer to that question. Regarding the what other questions are there? What's the difference? Yeah, that's a huge question. What's the difference about single square brackets versus double square brackets? So I have posted actually a link to the Stack Overflow discussion. So there is a lot of things to consider, but generally, well, people seem to agree that double square brackets are have more features. So if you're really working on Bash and not on a different shell like SH or any other shell with less functionality, so there are a number of shells. So we can, for instance, we can launch SH, and it won't have the double square brackets functionality. But if you're working on Bash or ZSH, then you have the access to a lot of functionality, including the double square brackets. So double square brackets are what we will actually use just now, and I will just demonstrate what's going to be going on here. So as we have seen here, I will just get into, what's the fuss with the square brackets using this example. So what we would like to do is we would like to ensure that this input HDFI file name is filled in. So how do we do this? So we need to actually understand that this input HDFI file name, this thing actually exists and is a regular file. So this test -f command will return a non-zero return code if the input HTML file name is a regular file. And also you could do it like this. You could also just test it like this, right? So let's use an if construct here, and if construct looks like this. If condition, then here are the commands, and then the fee. Question: What's the point to use Bash controlling script instead of using Python for it to? So, in my opinion, as much as I love Python, it's a little bit of an overkill to basically use Python for things like find -name, like this. That will just, you have a one-liner in Bash, but to use it in Python, you need to be importing external libraries. invoking library functions and doing like this, but you have just one-liner bash that is just 10 symbols long, okay? And for a lot of Linux and Unix programming, there exist one-liner bash scripts that are way more efficient, simple, and faster to develop. Yeah, so yeah, let me just, I'd love to, well, I don't really encourage you to read more on bash, except for for this. This is an absolute must if you would like to really understand the basics of bash. So let me show you this YouTube playlist. You can just do you can just turn on the double speed and do a walkthrough. It's 10 minutes. It's like 29 10-minute videos that one can use to basically learn a bit of bash. So let us, Kirill, I cannot answer 32 questions in the in a row. That's too much. Okay, yeah. So that is supposed to be opt. You're correct. Opt. Right. Then. So okay. So if we're looking at this variable, and if this test command, so this is really running a test command under the hood, then we would like to actually echo input file name or input file not set, and actually perform an exit indicating that we're exiting with an error. So step 3 loops, it's going to actually exit you with an error unless you have a set -c something. So -e something is not a file, really. So -f so that worked all right. Let's actually double check what the test command does. -f file exists and is a regular file. So I think it should actually work. Yeah. So if it exists, so the question was that I needed to check if the file does not exist, right? So it's not set or is not a regular file. So that's the way it works. So you can actually otherwise, so it doesn't exist, but if you input this readme, which exists and is a regular file, it will actually execute a this condition is false, then it will not go into this if clause. Then it basically it effectively skips the if clause and goes into echoing the input HTML file. Okay. So another way of doing the same in a one-liner would be actually this. So you demand that this input HDF5 file name is a regular file. So you demand this, but if it's not, so if this command returns false, then we can do like this. So that's a statement that's extremely frequently encountered in a bunch of Linux programs. So this is a one-liner, as you can see. So it does the same, except I probably didn't do it right. Yeah, so it has to have the semicolon. So let me let me do it like this so you could see. So this is one-liner. I think it should work, right? So this is a one-liner that does just the same. So let me skip to the version of the script where we already have implemented everything with the get opts. So here are a bunch of other options here. So as you can see, these are the checks for the input and output file names that they must be filled in accordingly. And now this is the same code that you have been looking at before. So you can check for yourself that the script actually works. So a few little things to note is that in here, the find program is a single-threaded application, right? So the find program does not parallelize anything for you. I have actually gone one step further and actually implemented a parallel version of the processing, which looks just like this. So it starts with finding all the files as previously, but instead of piping this through to the exec command, or instead of piping it through the read and executing a while loop, what it really does, it pipes it through the parallel program. So parallel is basically GNU parallel. It's actually a program that was really useful to build and execute shell command lines from standard input in parallel. So it has a somewhat creepy interface with all the columns and everything, but the fundamental way of actually working with this command is extremely simple. So you do the parallel, and then you specify the number of jobs that you want to run, for instance, the like 10 jobs, and then you just specify what you want to run. So the binary minus f, which is an input file name, all the parameters, and the this opening and closing square brackets, they actually hold the file names. So let me show you how this works real quick. So maybe I can just like this. So let me, yeah, that's one modification that I made, which is work in parallel. So we can just look at this htop program, which is going to show us when the script starts actually running. So now it's preparing the data with this merge preparation tool, and now it's executing the parallel and it's actually parallelizing it with just one job. So if you want to work with one job, that's because I haven't actually supplied it with the number of jobs, which is 1 by default. So sorry. So let us put like 30 jobs. Let's do it 30 jobs in parallel. So that's one modification. And while we're waiting for it, so one other modification that I made to this script is that I'm creating a temporary directory instead of hard coding any directories. So now it's going to be able to actually execute everything in parallel like this. And we will be able to see how the parallel program produces outputs as soon as they are produced, actually, because it actually prints the name. I think it prints the file name. It's supposed to, oh no, it's so it really does print the file name processed, but I have redirected the print the standard output to a separate file. So as you can see, the server gets pretty loaded. So yeah, okay, so let's stop here and see if we have any other questions. So that basically more or less concludes the part that I wanted to devote to the well, to shell scripts. Okay, and let us attempt to discuss something for maybe 5 minutes, and then we'll switch to Docker. Yeah, so the number of jobs is typically depending on the application that you're running. So I'm not sure what is cores that you mean. So basically, number of jobs is the number of independent copies of the program that get invoked. In this case, these jobs are separate programs that are managed by this parallel program that I was showing. If you have, let's say, one core, but you're trying to run it a 40-job application, that all these jobs will use the same one core, the same one physical core. So it has nothing to do with the shell script. It's just to show how you can speed up things when working with Bash. And the parallel is available for pretty much any Linux distribution. Yeah, so I see people really don't understanding why is Bash something that one should learn. Well, if you're using Microsoft Windows, then you can basically skip it. But if you're trying to be a programmer who uses a Unix system, then learning Bash is actually an essential requirement, because there's no way you could run a parallel program on a Slurm cluster, for example, without knowing a little bit of Bash. And additionally, most of the software that's being produced these days is supposed to be run under Bash, under Unix, under Linux-derived systems. And all of the software that we work in our computer vision group, well, it's written for Unix. And so to run it, you need to know how Unix works, and shell scripts are part of it. So as you have seen, in just under 2 hours, I have more or less created a wrapper for a code that I have no idea how it works, and made it parallelizable and more or less portable and more or less useful. So that was the whole idea of this first part here. Yeah. So yeah. So actually, so these the final files that were created as a part of this tutorial will be released in a separate repository that is will be publicly available over the internet on GitHub within 1 day, because we need to do a quiz after that today. So that's the first part. Where can we get the examples of the script? So, the examples of my scripts you will be getting after the tutorial, but the examples of other scripts, well, there's plenty of them on the internet, and you can just more or less, when you're trying to solve a particular problem, you will be Googling for it, and you will be typically getting the scripts as replies on Stack Overflow or Stack Exchange or anywhere else. So I more or less, I wouldn't recommend, reading a book on shell scripts. To me that sounds ridiculous, but I would recommend going on a case-by-case basis. So if you're having a problem, you're trying to solve it, you're trying to basically do it yourself. If you're unable to do this yourself for like 5 minutes, then you're Googling for it, and you're typically, there's a lot of answers that have a lot of questions that already have an answer here. So I need to be switching to the second part here. So for the second part, even though we have been doing a lot of work to get this script done and more or less usable, there's still one super major flaw that it has. So the problem is with this contrib. So the contrib is actually a lot of libraries that this code actually needs. So in this case, what it needs is this library Seagull, that is actually a large library with a lot of dependencies on its own. The second thing is this application on C++. The third thing is the Python library, which consists of several scripts. And this Python library is actually has its own dependencies, right? So if I was to move all these scripts to a different machine, then I would immediately encounter that they don't have the required libraries installed, and that I will have to configure them again, for instance, by running this prepare script. This is not generally convenient. So something that people have been using to more or less save their time and being reproducible and being able to deploy things on a lot of machines is this Docker container idea. So for the Docker container, let me first actually talk a little bit what is going on with the Docker. So yeah, for the Docker, one of the useful things to start with would be more or less Docker documentation and the official repository for Docker that is over here. So let's do it on a practical way, okay? In a practical way. So if we're working with Docker, what is a Docker? So Docker first is a Linux program. It's a normal Linux program that has a command line interface, that outputs something and so on. So there's no magic behind it. So Docker has to do with what's called images and containers. So let's just try doing things, and I will explain them as they sort of appear. So to run anything with a Docker, we first need an image. So an image is generally an operating system inside an operating system. So I'm here with my Linux machine that has all the programs inside it. So it's sort of built in into the machine. So there's an OS that manages this machine. So Docker is a program inside this machine, but Docker image is a sort of a separate virtual machine that is inside my physical machine. So to run anything with a Docker, I first need to get the image. So the image is just a distribution, if you would like. So previously people were downloading, CDs and DVDs, and now we can just in a similar way you can basically think of a Docker image as a virtual file. So it's basically a file, a physical file that contains a virtual OS. So let's start with downloading an image. So it's actually the Alpine, so it's done with using the Docker command. So the Docker pull basically pulls an image from the remote repository. So for instance, you can pull, I don't know, NVIDIA /CUDA, but it's sort of, so that's the way it would look like. So it's basically pulling from NVIDIA /CUDA. What is it that it's pulling from? It's from the Docker Hub. So the Docker Hub is a large collection of images that anyone can use to actually, build applications and ship them without the containers. So what this command is going to do is really going to physically download a lot of data from the internet and save it on your local machine. So now we have downloaded, for instance, this NVIDIA CUDA latest, right? So we can basically look into what we have as a collection of images on this machine. So Docker is actually a command line application. So the Docker command line interface has a bunch of commands. So one of these commands is Docker image, right? So the Docker image has the list option here. So you can look into which images are available on your machine. So all of these images are more or less separate operating systems or a virtual operating systems that you're able to run on your machine. So this Docker pull, it has fetched the image from the Docker registry and saved it to our system. So the Docker image or Docker images, it basically lists, so we can see a list of all images on our system. So let us actually run something inside a Docker container. So to run something inside the Docker container, you could just put a run, say Docker run, and type in the name of the container and then type a command. So for instance, you can do ls-l, and I'm not even sure if the command will actually run. But there's some Docker containers, they are actually unable to start on a system due to certain hardware restrictions. But this particular container was able to start on the system. So what happened? So behind the scenes, when we have invoked this Docker run, a lot of stuff has happened. When you call run, so the Docker command line interface has a Docker client that contacts the Docker daemon. So actually, there is a Docker daemon that is actually running behind the scenes that we don't see it, but it's up and running in our system. So this Docker daemon is more or less the manager for all the containers and all the images that are on this particular machine. So each Unix server should have its own Docker daemon up and running. So this is more of a housekeeping program here. So the Docker daemon, it's actually supposed to check the local store for this particular image. So it must understand that you have this NVIDIA/CUDA:/latest available locally. And if it's not available, it is going to download it from the Docker registry. But because we have previously downloaded it using Docker pool, it's already available. And so the download is not necessary. Now, the Docker daemon creates the actual container and then runs a command in that container. And then what happens? So this is launching the container, and then the Docker daemon is actually streaming the output of the command to the Docker client so that we are able to actually see the output of this command. So for instance, one typical use for the Dockers is to invoke the NVIDIA CUDA libraries, for instance. So we can try, okay, so it's not available on this image. Okay, cool. Okay, so let's try something a little more exciting. Hello from NVIDIA, something like this. So it's just going to basically output hello. So all that, if you've noticed, all of that is happening pretty quickly. So it is much faster than actually booting a real virtual machine, running a command, and then killing it. So this is why the containers are so fast. So we can try actually running bean bash as a command if it's available on this particular. Nothing has happened. Is that a bug or something? No, it's not a bug actually. So this bean bash is an interactive shell. So it means that they will actually exit after running any scripted commands unless they are run in an interactive terminal. So to run this bean bash in an interactive way, we need to supply. So there's actually minus interactive and actually TTY. So this way we will arrive in an interactive terminal with this with the bash. So now we're in a container. So we're actually executing. You can, for instance, you can try to check what's the host name. So the host name is the hash ID of the container. And if I press Ctrl D, I will exit the container, and my host name resets back to the actual host name of the machine. So for the, let's actually, for this command, you can, of course, you can use all of the normal bash commands that we were using previously, for instance, ls or find lib, or do some shell scripting. It even has some of the editors probably, but not the vi or vim. Maybe it has nano. Now it doesn't have nano. So you can do the uname or something like this. Uname. So it's a normal Linux 1604. So let's check with the running containers. So at each time on a machine, some of the containers may be running. So to check which containers are up and running, we need to execute the docker ps command. So the docker ps command actually prints you all the containers that are running. If none are running, you will see a blank line. So actually, for more control, this PS has a lot of options. One of the options is -A or -- all. So you will see that the machine has actually many more containers that are not running, but that have exited. So as you may see, here are the actual exited containers for the commands that I have been running previously. So for instance, this is the latest container that I've been running. So it says that the status is exited 48 seconds ago. So why is it visible? So this is visible because the containers are not removed just after they have been running, after they have been exited. Okay, and on this particular machine, there's a huge bunch of containers that were exited but not actually removed. So to, for instance, to remove a container, we can do docker container rm, and then, for instance, put in the hash name of the container like this, and it's going to print it back and just remove the container. So let's walk through a little bit with the terminology here. So with the terminology here, what we have is an image. So the image is the file system and the configuration of the application that I use to create containers. So, for instance, one thing that you might want to do is to see what's actually in the image. So, for instance, there is this image that was named NVIDIA/CUDA, right? So we might want to actually inspect this image. So to do that, there is a docker image inspect command. What it does, it basically outputs you a huge JSON with all the possible information about this actual image. So what information it has? It has some of the tags, it has the parent, it has the configuration of the container, so environment variables. It actually has a lot of variables built in. There is a default command, and there are some versions and things like that. So a lot of things are available to view on this Docker inspect. So the container is a running instance of the Docker image. So the containers run the actual applications. So container includes an application and all of its dependencies. It actually shares the kernel with the other containers and runs as an isolated process in user space on the host OS, okay? So in here, this Linux machine that we're working on is a host. So there is a host operating system that controls it. So the physical space, the physical processes running in this the host OS is divided among the containers. So the list of the containers is basically can be seen using the docker ps command, okay? So then there is a Docker Daemon. The Docker Daemon is basically the background service that runs on the host that manages building, running, and distributing Docker containers. So the client is a command line tool. This Docker program is really the command line interface to the Docker client. So it's actually some software that is accessible by the user to interact with the Docker daemon. And then there is this thing called Docker Hub, or the Docker registry, which is a collection of enterprise-ready containers and plugins and Docker editions. It's actually very useful. So what do we do? What do we do next here in this? If you have any questions, please do ask in the chat or out loud. So what I would actually like to do is I would like to actually put all of the dependencies that I have into a separate Docker container, so that I don't have to do anything to configure the environment for a different machine or anything like that. So in this particular tutorial, I have actually prepared all of the necessary environment already. So let's first start with using it actually. Okay, not creating the environment, but rather using it. Let's try using it. So the Docker image list, it actually contains the tutorial environment, the tutorial image. So this is the name of the image, and this is its tag. So images may be tagged. If an image has several versions, these versions can have several tags. So these tags are needed to basically uniquely identify an image. So let's basically Docker run tutorial, and then the colon separates the name of the image from the tag. So what I want to do is I want to run it in an interactive mode. This means that I will need to actually provide the -it command, and then I would like to remove it afterwards. So -rm. So -rm tells the Docker daemon to actually delete the container once it has finished running. So now we are in a container, right? So the host name gives us the hash ID of the container, and we are now a different user. So who am I will actually print that you are a user named user, and for instance, the environment variables are different and everything is different. So I'm in a completely different system now. So what I would like to do is I would like to go to my home directory. So I can see that in my home directory, I have a few subdirectories. For instance, this directory called code, it actually already has all the necessary codes that are needed to actually execute some of the things that I want to execute. For instance, it has a pre-built Voronoi application. So this is the binary that we were previously building by hand. So in this container, this binary already exists. Okay. Another nice option is that, for instance, I already have the NumPy configured, the NumPy Python library configured for me, and I have more Python libraries that are built into this container. So if I would like to do, if I wanted to, I could just copy the container to a different machine, run it on a different machine, and I will have the exact same environment of that particular machine. This means that I will actually have portability, so reproducibility. This is what I will have. This means that I can distribute the Docker images across machines and be sure that the environment contains all the necessary dependencies and all the necessary libraries inside it. So how do I use this actual container? So let's say I would like to process some of the point clouds that I was doing previously. So what I need to do is I need to first access the data. So as you can see, there is no the home. It doesn't contain. It's a separate machine. It doesn't contain what it contains in this machine, on the host machine. So on a host machine, we have a lot of users with their homes, but they are not available to this Docker container. Okay, so what I need to do is I need to run this container and actually provide access to the data in this container. So how am I doing this? So to do this, I can use the -v or the bind, and it works like this. So it works like host dir colon container dir. So what let us actually map some of the, so this is the host directory that I would like to map to a container directory. So for instance, let me map it to /data. So as I run the container, maybe bind is a bad way of doing this. Sorry, I first need to, the way it is done is like this. So you need to first supply all the options and later pass in the name of the container. So the name of the container should always go last. So now I can access my data here, and it's just the same data that is in this host directory on the original physical host operating system. Okay, so this is the original files. So they get mapped to a container directory. Okay, so this is not everything that we need here. Okay, so to actually work with these files, what we need is we need to map another directory that is home, repos, Skoltech, and then the contrib, and then actually there is the Python library that I would like to map to code to have access to this Python library inside the container. So let me run it once again. So now there's code that has this HDF5 utils. So as you can see, so let me actually show this to you. So Docker PS shows that I'm running a container, amazing Knuth, and we can actually inspect the container. And as you can see, we have, let me show this, we have mounts here. So these are the mounts that I have done. So it's actually binding the source directory into some destination directory with read and write permissions. And well, it's not actually going to have the write permission, but it doesn't matter. And it's binding this Python directory into code, okay? Now, what I would like to do is I would like to actually, well, more or less do the same script in here. So this particular script is something that I would like to use to actually, well, process the data. So let me also map it to a container as a third way. So actually, I can do it in a very similar way, but I would like to actually map the session to Docker, to code. Let's do it to the shell scripts like this. One thing that I will need to do So I have this run Voronoi here. So run Voronoi is exactly the step 5 here, okay? So let me try running this. So I have the shell scripts here, and I have run Voronoi here, and also have the src, which just contains the C++ file that forget about it for now. So if I try to do run Voronoi, so -e would be /data, right? Because we have all the files that we would like to process are mapped to data. So this is the file that I am selecting. And then there's the -o, which let's say it will open to, well, temporary file, to just test.hdf5. Or maybe let's do this to home user test hdf5. This is the directory that is most certainly writable. So there becomes, we run into a problem because we are relying on the relative paths from the actual run Voronoi script to the Python library, okay? So now we need to fix this path. So I'm editing this file here. Let us find where the actual Python source dir is. So this is the Python source dir that we used to have when we were running this on host. So let me actually comment this out and actually edit this so that we have the actual code in /code/hdf5 utils. Okay, so it's really there. It's whole code hdf5. It exists actually. Okay, so this should be the correct path. So I can just remove this for now. So the Python source dir is absolutely okay, but then there's a binary directory, which is also broken now. So let me edit also the binary directory here. So the binary directory is in home, user, code, and then there is the Voronoi, and then there are all the binaries here. So the binary directory is actually home, user, code, Voronoi, okay? So let me edit this as well. So now this script is supposed to run and will fix most of the errors as we see them actually. So as you have seen, as you see, it's more or less working. So let us check if it's not gonna actually fail somewhere in the middle. Well, let's hope it doesn't, because we don't have enough time. Okay, so about the log. So I haven't told about this, but actually I'm running the parallel and capturing its output. So let me show you this. So you can actually redirect the standard input and the standard output for most of the programs into files. So for instance, if you are doing ls and it prints you a lot of things, that you can do ls and then type the greater than sign that sort of looks like an arrow and then redirect it to a file. So it doesn't print anything on the console, but what it instead does, it actually writes a file with all the things that otherwise would have been printed into the console. So in here, it's the same construct. Actually, this directory is not writable by the Docker. I will just remove the redirect for now, and that's pretty much it. And also we have been using the number of jobs that is more than 1. So let me also show that it actually works. So this is the very same script. We have edited 3 lines exactly, and now it is running on an entirely different machine. So I'm not sure. So yeah, so it's actually now it's working in Docker. How to see if it works in Docker? So I'm running an htop command, okay? So htop is actually, if you press F5 in htop, it's actually capable of showing you all the tree of spawned processes. So as you see, we have a lot of processes running on this particular machine. So let me find what is the process that that runs this code for us. So here is the process. So the tree of the invocation tree is like this. So these are the binaries that are actually executing. So they're supplied with the input and output file names by the parallel program here. So this parallel program is actually a Perl script. So Perl is a freaky, creepy programming language for web development that is still extremely popular. So this Perl script is invoked in turn by the bash script. So this is exactly the bash script that I invoked by hand, okay? And this bash script is invoked by the container. So this container is actually displayed as a run container init here. So it's still running here, and I hope everything is going to be actually okay, except, no exceptions, it should be okay. So one thing that is still bad with our script, let me stop it for now. One thing that is still bad is that we actually have to run the container manually and type into the run script. So you have to invoke the bash script manually in here. So to not do this, we can do one of the following things. So one thing could be that we could actually run the script by hand like this. You can actually do bin bash and then -c and then provide the command line that you would like to run. So this you are invoking score shell scripts, and this is exactly the same thing. This is doing exactly the same thing. So what this actually does is you run the container in an interactive mode, mapping all the necessary files, mounting all the necessary directories inside the container at certain locations, and then you execute a command. So let me show this. So you execute the actual command. So this is the actual command that gets executed instead of the entry point. And it runs in the same way as it would run should it have been executed by hand. So I think some questions should exist here, right? So please do ask. Let's stop for a couple of minutes and maybe discuss it. What is not clear here?
Well, I would like to ask a question, and first question is, can we ask questions during your talk or during the lecture, or
Yes.
we can ask it only during dedicated periods like this one?
You can just ask questions out loud whenever you want.
Okay. and the more content-related question is, like, what was the purpose of the last 5 minutes? So I didn't quite get it. So you created a console command that emulates another console command, or what's going on here?
No, so the idea of using Dockers is that you will be able to actually run all this code without well, in the same way on any machine. So you don't need anything to run it. You don't need to set up environment, conda, build binaries, do anything. So it's all inside the container. So what I was showing is that you can basically run the bash script, or you can actually inside in an interactive mode inside Docker, or you can just do it the same way by passing all the necessary parameters to the Docker command line.
So the things in quotation is the command that's going to be executed inside the Docker.
Yeah. So the syntax is like this: you do Docker run, then options, then the image name, and then the commands. So in this case, bin bash -c, like this, it's more or less invoking bash interpreter, passing the commands in quoted and double quotes into the into the interpreter. So for instance, you could do something like, my var is 123 echo, I don't know, echo dollar my var, in case it's gonna work. Well, it's not gonna work. Maybe you should export. Sorry.
But you put interactive flag. Wouldn't it? Well, isn't it supposed to run an interactive session?
Yeah, it's really not supposed to work to run an interactive session. So it's not necessary to put in this flag, I believe. So it should work in the same way. So interactive session means it's attaching to a teletype interface and expecting user to type something in from the keyboard. So this is not the case when we're running. But in this case, as you can see, I cannot stop it. So I press Ctrl C and it doesn't work because it's not. There's no terminal attached to it. It's just printing things. So to stop the container, I will need to do the Docker ps, understand what's going on, and then do the Docker stop and do like this. But it's not going to happen for at least a few seconds because Docker is first trying to stop a container that doesn't do anything, and then is failing back to actually killing a container. So this container has been killed because the stop command, it wouldn't respond to a stop command. So the link to the recording of the webinar will be provided by Evgeny after the seminar is over.
Oh, so if you just put...
we have 15 minutes left, so I will say that let's Alexei finish it, and then at the end we can have some round with questions.
All right. So yeah, about finishing. So so as you can, we more or less achieved our goal of running things in a container. But the tricky thing is actually how do we create this container, right? So we have seen. So let me close things so you're no clutter on the screen. So we have seen this Docker run commands, and there are a bunch of other commands. For instance, Docker stats displays real-time statistics on resources consumption. We have a lot of others, so you can Docker login with actually authenticates you into the Docker registry, so you could actually push images and not only pull them. So you can do a lot of things for orchestrating the Docker containers, but the most important is probably Docker build. So the Docker build is actually a program that builds an image. So how is it building an image? So to build an image, I go into my directory that is supposed to have a particular structure. So this directory has to have a special file that's called the Docker file. So the Docker file is actually containing instructions about how to create the container. So this is a Docker file that has been pre-built for you, well, basically by one of my colleagues, specifically it was Gleb. Let me explain what is going on here. So if I do the Docker build minus, so you just do Docker build and then the directory name, then it actually what it does, it basically tries to build the container. But because this image, the image, not the container. So what it actually does, it's well, communicates with the daemon and actually performs a bunch of steps. So let me first demonstrate how this actually works. So to do this, I need to Docker image list and then find the tutorial container. I will need to actually image remove tutorial :latest. So I have deleted the image. Now this image is no longer on the host OS, and I will build the image. So as you can see, what it does, it actually more or less executes all of the commands that are written inside the Docker file. So let me show them once again. So they're just executing now. So if you just stare at the console for a while, you will be just seeing that this actually builds the library, and then it builds the binaries, and then it creates the Python environment and does a lot of things. So so this Docker file is a text file that contains a bunch of statements. So each statement looks like this. So it's a uppercase instruction, and then there are the instruction parameters. So instructions, there is only a fixed, a limited number of extra instructions that exist. For instance, this from instruction instructs the Docker build command to start with the image designated by this name. So Seagull/testsuite Docker Ubuntu is actually a name of the image that exists on the Docker registry. So you can do the Docker search and then ask for Seagull, and it will output you that there is an image that is so it's the name of Seagull/testsuite Docker. So the Docker image and the OS that gets built when this Docker is built will already include everything that is inside the Seagull/testsuite -Docker image. Then the maintainer just sets a string name that says who's the maintainer. Then one really important instruction is the run instruction. So instruction run is actually instructing you to basically execute something as if you were doing it in a command line. So you can do the apt-get update when you are when you have sudo permissions. If you do like this, and I have a sudo permissions on that machine, so it will just update all the repositories checking this, right? So this is a single instruction, in fact, even though multiple commands are actually executed here. So this instruction says that I need to run get update, check its exec status, so the return code gets checked. If the return code is 0, that means that everything is okay. It will actually launch the second command, that is apt-get install with some options of these Linux packages. This is the normal apt-get install that you will always do like you usually do. Then one important thing to understand here is that each instruction actually modifies an image. So this is an atomic operation to the image. So this whole run apt-get update will only result in one step as depicted by this step meter here, right? So if why is this important? So this is important because Docker build is incremental. So if you are trying to build an image and all these commands execute successfully and this command fails, then the image will not be finished building. But when you fix the bug that prevented this command from being successful, so if you fix this bug, then you will not start from scratch. You will start from the last successful command. Of course, you can do a rebuild, but by default, you will start from the last successful command, from the last successful step, okay? So now what is happening here is, well, basically the commands are being, we're actually building the Seagull library. So as you can see, it's just executing the same commands that you would do if you were, working in the normal command line. Then it installs the binaries, then it adds the user. So you do the, well, what it effectively does is this, add user, which with the name of user, you can add them to sudoers, and you switch the user. So this user instruction actually switches the user. So if this user is, so one might ask, okay, if now I am a user, so who was executing all these commands before? So before we switched users, it was root. So all this apt-get update, apt-get install, and all these commands were executed by the root user. So root user has, of course, the super user privileges, so it's possible to actually destroy the entire system if you are not very, accurate. If you are nasty. Another important instruction is the env instruction that sets the value of the environment variables. So inside the Docker, for that user, we will set the environment variable home to home. So I see we have like 5 minutes left, and I'll be extremely fast. So most of the commands are just normal commands that you will execute in bash. So one important thing is to copy the necessary files inside the container and change the ownership if you would like to actually build it. And here we have session 2. So here we have this src directory that holds, or the source code that I have here, and it only contains a make file and a C++ binary that I need. So the source code is being built here. So you actually copy the source code into the container, into this directory, and you run the make program. And the make program actually, well, basically it makes, it compiles the binary using the make file. And this is something that we are not covering here, but what it basically does, it just does the C++ Voronoi CPP. That's what it does under the hood, and it just links to a bunch of libraries, including the Seagull here. So, so more or less that covers the Docker, but of course there is much more to it. So currently, I don't know any perfect, ideal Docker tutorial out there, but I will try to find those. And I will try to share it with you. And in the meantime, I will actually finish now. And I can imagine that you have a lot of questions after this, super quick tutorial about Docker. So what we really could do now is stop here, and maybe you could type me more questions about, more questions that you could have. Of course, containers are a rather broad topic, and to learn how to make them, 1 hour plus something is not enough. So I propose to ask questions and maybe send them to myself or Rodrigo or whoever is managing the course, so that we can provide maybe an answer after the seminar. So one question: do I need to compile something inside the Docker for GPU to work? So the Docker must support the software required to use the GPU. So if your machine has a GPU physically, then you have to have a GPU driver, and you have to have the CUDA software, for example. So the Docker, so for instance, this NVIDIA CUDA Docker, NVIDIA/CUDA, is an image that basically contains all the CUDA libraries here. So one thing about running this Docker is that you should either run it using the NVIDIA runtime. So it runs like this, runtime NVIDIA. Docker run, let's say -IT, -7, runtime NVIDIA. And then everything is available. Or you could use, instead of runtime NVIDIA, you can use NVIDIA -Docker. It's more or less the same. If you look into the script, it's more or less it's more or less the same. It's more or less an alias. Who should use the Docker? So everyone should use the Docker. That's the correct answer, more or less. But the question, I think, is if I don't know how to build containers, how to build images myself, then at a technical level, a lot of containers exist that are pre-built for you. For instance, this NVIDIA CUDA. There are PyTorch containers. There are TensorFlow containers at every possible version that you could, get. And basically, you can just use an off-the-shelf container from the Docker registry. You can pull it, and you can pull the needed version, and you can just use it. If you need to build a container yourself, an image yourself, and run it inside a container, then you will have to learn how to use the Docker files. It's not that hard, but there are some tricks. And well, they're basically there are basically a lot of resources about building. So there's an entire Docker file reference here, and so I have no idea about Windows. I don't use Windows, so I cannot comment on that. I'm sorry. If you need to, so what's the difference between TensorFlow that comes in a pre-built Docker image and the TFGPU installed with pip? So short answer, there's no difference. Long answer, well, you don't have to install it with pip. And well, you don't have to, if you need a different version for a different project of the TensorFlow, then you don't have to reinstall it or fiddle around with virtual environments and everything. So you can just run a different version of the Docker container. And if you need to use both TF and PyTorch, then you can probably create a separate image and then just do it manually. So it's not that hard, really. I think we need to stop here.
I would like to add to emphasize why we need Docker, especially from a researcher's point of view. And it is that often we have collaborators or we are publishing, and one of the biggest problems is reproducing the research. And this is because we don't really know which version the author was using, what was the configuration of the computer, and so on. And with Docker, we can abstract all this. We can set all these details into the image, so then the person with whom we're sharing our research just needs to run the image, build the container, and immediately has exactly the same environment that we use to do our research. So this is very powerful. And also considering that we are constantly doing many experiments, we need to be changing libraries, little configuration details, and so on. And it's not a good idea to do it directly in our computer. It's much more efficient to do it in an abstract environment such as Docker.
Okay, guys. So thank you for your attention.
Okay, we'll try to
so
evolve the course, so maybe we can include a little bit more.
We'll also
in
the chat we will also send a link with Google Doc. There you can add your comments, ideas on the course and then its content. The next time there will be more things about software engineering, plus some exercises, I guess. And today we'll send you some quiz so that you can refresh your knowledge, and then we'll of course share the materials for today's. Okay, guys. Thank you, everybody. Bye.